All right, children, the time now is 5:30. Wow, Janelle, you turned on the camera on the dot at 5:30. Good job. All right, so children, welcome again. Welcome to Sec 1 Math lesson number 2. All right, hello, Victoria. Yeah, so today, right, we'll be going to do prime again. Optimus Prime, you all know? Okay, y'all never watched Transformer. Okay, never mind. All right, maybe y'all watch something else. Okay, so today we'll be doing the second part of prime. All right, and today mainly we are doing something called perfect cube, perfect squares, and all this. All right, so along the way, right, I'll be letting in students. All right, most of them are late. All right, but they are still trying to come in because I think the timing a bit too early for some of you. All right, hello Devon. You see? All right, so children, so today, right, today we have to finish a couple of questions from last week work. So last week I talk, right? I talk so much. I give you the beautiful notes, all right, until I didn't manage to finish some of the questions. So we'll start off with last week's questions, all right, about 2 or 3 questions. Then we'll go into the notes for this week. All right, then along the way, we'll be doing a little bit of Kahoot. I hope today we can do it, hopefully. Okay, so that's the plan for today. All right, anything you can just unmute yourself. All right, you can unmute yourself or go to the chat or message and just type in your message. All right, then I'll be able to see from there. Okay. Okay, so today our first question is actually question 3. Question 3 from where? From worksheet 1. All right, so children, last week I didn't manage to finish this question. So today I want to talk a little bit about it. So we are into the topic of what? We are into the topic of prime, right? And under the topic of prime, right, we talk about something called prime factorization, remember? All right, this is a method whereby you use the prime numbers. Oh, prime numbers, remember? 2, 3, 5, 7, 11. All right, these are the 5 numbers I told you to remember last week, correct? All right, we did something called prime factorization. After that, we go into something called HCF and LCM. All right, HCF means highest common factor. LCM means lowest common multiple. All right, so that is the thing that we did last week. Okay, then now, they bring out a question like this. All right, they bring out a question like this. So whenever you look at a question like this, like hello Xuan Xuan, right? Whenever you look like every time when you look at a question like this, right, you must understand, this type of question, right, can either be a HCF or LCM. All right, this type of question is under the topic of prime, and it can either be HCF or LCM. All right, so you have to choose either or lah. All right, but later I'll tell you how to make a better choice. Is it HCF or LCM? So let's just take a look at this question first. If there are 270 pencil, 198 notepads, and 108 markers, yo, so many things, All right, you got notepad, you got pencils, and you got markers. It's like the Sec 1 orientation. All right, maybe you're Sec 1, you're coming into school, right? Then maybe your senior, right, they'll prepare some gift for you. All right, they'll prepare some gift for you, which consists of pencils, notepads, and markers, something like that. For example, lah. All right, but if you never receive gifts from your senior, it's okay also. All right, I'm just giving an example. Okay, they are to be distributed evenly to as many students as possible. All right, you want to distribute all these items to as many students as possible. If it is me, right, I will just distribute to me lah. All right, me equal to 1 student. Can you see not? So can one be the answer or not? If it's me, it's 1, right? It's just me lah. So I will receive all the 270 pencil, all the 198 notepads, and the 108 markers. Cannot? Can. I will receive everything. All right, I will receive everything. Can. Or maybe I say that, okay, maybe the maximum number of students is only 2 lah. Me and Brian, right? Because Brian just come in. All right, so me and Brian. So can 270 be split among me and Brian? Can. Can 198 be split among me and Brian? Yes. Can 108 be split among Brian and me? Can. So the answer can be 1. It can be 2. Correct or not? Can you see or not? Can you see or not? All right. Can the answer be maybe 3 or not? All right, can the answer be 3? All right, so you have to check whether 270 can divide by 3 or not. Can leh. 198 can divide by 3 or not? Hey, children, last week I told you this. Look at these 3 numbers. You add them up. 1 plus 9 plus 8 is a 18. 18 is a multiple of 3. Means what? This one can divide by 3. 198 can divide by 3. Don't believe, press your calculator. 198 divided by 3 is 66. You see? Can. 108 leh? Again, you take the 3 digit and you plus together. 1 plus 0 plus 8 is a 9. 9 is also a multiple of 3. So 108 can divide by 3, which is equal to 36. Right? So 1 is the answer, 2 is the answer, 3 also. Right? So these 3 students is me, Brian, and Janelle. So can. Hey, but children, is 3 the largest number of students? Sure. Like that, I keep on guess and check until when? Precisely, lor. All right, so it will take a lot of time. So don't go and guess and check. But the idea is something like that. The idea means that it can be shared with 1 student, or it can be shared among 2 students. It can be shared among 3 students. You have to list out until you find the biggest what? Biggest number down here. All right, the biggest number of students. So how do you do that? Right. So for this type of question, right? One look, right, in future, right? You must know that it is a what kind of question? Is it a HCF or LCM? All right. This type of question is what I call a HCF kind of question. All right. This type of question is what I call a HCF kind of question. Okay. Highest common factor kind of question. Right. How do I know? All right. How do I know? You have to look at some of the clues. All right. Down here, they will usually ask you to find what? The greatest number. All right. The greatest, the maximum. All right. Something like that. So every time you see all these words, right? Greatest, maximum, it actually means what? HCF. All right. So this is just an idea. Usually it's like that. Whenever you see the word greatest, maximum, biggest, largest. All right. Largest. All right. All these words representing big is actually for the highest common factor. All right. And look. I'm going to sidetrack a bit. I'm sorry. I'm going to sidetrack a bit. Look here. This is our question. Can you see not? There are 3 different bells. The first bell ring every 15 seconds. Dong. The second bell rings every 40 seconds. Dong. The third bell rings every minute. Dong. If they ring together at the same time, what time will they ring again together? So every time you see this word togetherly, all right, you see this word togetherly or simultaneously, all right. So this word together or simultaneously is like togetherly, right? They must do it together, one. All right. This type of question is a LCM kind of question, lowest common multiple kind of question. Right. So this is something which I think is useful to you. Sometimes you have to decide, is it a HCF or LCM question? You look for some of the keywords. All right. Sorry about this. This one, let me go back at first. All right. Later I'll come back to this question. Okay. All right. So down here, they ask for the greatest, the largest, the biggest, the maximum. All right. You have to look for something called HCF, highest common factor. All right. So down here, what do you do? Oh yeah, sure. Highest common factor. Can I use the lovely method? Lovely. All right, this is called the lovely method. Remember this? All right, so we write the 3 numbers, basically 108, 198, and also 270 on this lovely line, this L line down here. All right. Then after that, what? We are trying to what? We try to divide by the common what? We try to divide by the common prime numbers slowly until it cannot divide. All right, then that would be your HCF. All right, so I don't know if you can remember the notes or not. All right, for those who appear, all right, who come for the lesson last week, check this out. Remember this? Woo! Ooh, 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 ooh. All right, so down here is your lovely method. It's not bad. Come for lessons, still got sound effect. Right, all from me. Not bad. Right, sorry. Okay, so down here it's called the lovely method. Lovely, lovely, lovely. All right, so we are supposed to use the prime numbers 2, 3, 5, 7, 11, right, to slowly divide. All right, and we divide until we cannot divide by the same prime number. That is your HCF. All right, so what am I talking? Let's talk about this question again. Okay, so remember your first 5 prime numbers is 2, 3, 5, 7, 11. All right. So down here, what do you see? The first prime number is a 2. So looking at these 3 numbers, right? Can you see not? All 3 of them are even number. Woohoo! All 3 of them are even numbers. So can divide by 2 or not? Yes. Yes, I can. All 3 can divide by 2. Let me divide by 2 first. Starting is 2. So what do? 108 divided by 2 is 54. Write it down. 198 divided by 2 is 99. Write it down. 270 divided by 2 is 135. Write it down. All right. Can I divide by 2 again? 54 can, but 99 and 135 cannot. So how? So you don't use 2 anymore. You understand? Right? All 3 must be able to divide by the same prime number. If not, skip to the next one. Next one is a 3. Come, let's divide by 3. What is 54 divided by 3? 54 divided by 3 is equal to 18. What is 99 divided by 3? 33. You see, all 3 of them can divide by 3. 135 divided by 3? 45. Okay? Hang on. Can we try to divide by 3 again? Let's see. 18 can divide by 3? Yes, give you a 6. 33 can divide by 3? Yes, it gives you an 11. 45 can divide by 3? Yes, it gives you a 15. Woohoo! And children, you stop here. You ask yourself, any more number down here? Any more number, all right, which can be used, all right, so that these 3 numbers, right, when it divide by the next number, it can be divisible by 1. Got or not? All right, can we divide by 3 again? A 6 and 15 can, but 11 cannot. So cannot already. Cannot use 3 already. Cannot. All right. Can we use 5? 15 can divide by 5, but 11 and 6 cannot. Can we divide by 7? 6 cannot divide by 7. Sure, nothing else already. 7 is more than 6 already. Nothing else. So what you do? You stop here. And this portion is what you call your HCF. All right. This portion is called your HCF. Okay, so this portion is called your HCF, which can be written as a what? Which can be written as a product. All right. Product of prime factors. Remember the term. Remember the English words down here. The product of prime factors means you can write as 2 times 3 times 3. All right. And you can simplify it to become 2 times 3 squared. Can you see not? 3 squared means what? 3 squared actually means what? There are 2 3s, what? Right, there are 2 3s, so you can write it as 3 squared. Right, this format is also called what? This format is also called index notation. Right, so children, you must understand the math term that we speak about every time. All right, hello, we have one student, Alvin, is it? Yes, welcome to join us. All right. Oh, and another student, Elisa, is it? Elisa? All right. Sorry if I pronounce your name wrongly. All right. So sorry about it. All right. If you want to, if you want, you can turn on your video, children. All right. That is actually one of the compulsory thing to do. All right. So that I know that you are behind the screen. All right. If not, then some of you might be playing Minecraft and not fully focusing on me. All right. So if you can, if your camera is working, please turn on your video. Thank you so much. All right. If you have a question, you can just unmute yourself and you can ask me. All right, you're Sec 1 already, you're old enough, so you will not disrupt the class. Or if you want, you can drop me a message inside the message box. Can? All right. Can I just check, is Alvin now? Alvin, are you there? Can you give me a thumbs up at least? Oh, okay. Yeah, okay.